Hey guys, Mr. Middleton here. Today we're going to talk about inequalities. At the end of this video, you should be able to determine whether a given number is a solution to an inequality, and you should be able to find and show all solutions to an inequality. Alright, so a little bit different than equations, but let's refresh and get kind of ready by solving an equation. So, we want to find the solution to this equation, 3x minus 4 equals 11. Alright. When finding a solution, we're looking for any numbers that make the equation true. Okay? In other words, the left side of the equal sign is equal to the right side when you plug in the number. Okay, so the solution above, we have 3x minus 4 equals 11. We'll add 4 to both sides. 3x equals 15. Divide both sides by 3 and we'll find that x 15 is 5. Okay, so 5. 5 is the number that makes this equation true. Because when I plug 5 in, I have 15 minus 4 is equal to 11. The left side equals the right side. What about with inequalities? Well, the prefix in means not. So therefore, inequalities means not equals. Okay, and we got a lot of words for not equals, or not necessarily equals, I guess. Here, this symbol says greater than. Okay, important, especially if we have word problems that we'll set up, getting those correct. This says less than. We're always talking about the thing that precedes the sign. Okay, so remember the alligator eats the bigger number. This says greater than or equal to. This is less than or equal to. And we can do that sign underneath just means or equal to. And this just means not. This just straight out says not equal to. Okay, so if a solution to an equation is any number that makes the equation true, a solution to an inequality is any number that makes the inequality true. The difference is that with an equation, there is one solution, or typically one solution. While with inequalities, there are infinitely many solutions. Okay, but we're not going to put infinitely many solutions a bunch of times. Okay, there are a lot of solutions, but there are, we'll say, borders to those solutions, and that's what we're going to identify as what those borders are, so that we can find out where our solution set starts and ends. Okay, so of the numbers listed, circle the ones that are solutions to the inequality. And here what we can do is we can just plug these values in and see which ones work. Is 6 greater than or equal to 9? No. Is 13 greater than or equal to 9? Yeah. Is negative 25 greater than or equal to 9? No. Is 9 greater than or equal to 9? Well, because it says or equal to, the answer is yes. If it just said greater than 9, would not be greater than 9, so it wouldn't be a solution. Okay? Now it says 6 is greater than 2. Yeah, 6 is greater than 2, so 2 is a solution. 6 is greater than negative 18. Yep, I'd rather have $6 than negative $18. 6 is greater than 15. No. 6 is greater than 6. No. It's equal to 6, but it's not greater than 6. Okay, you can plug in those values as well and find your answers here. Please do that for number 3. Bring that in mañana. Find another language to say tomorrow in. Alright. Since inequalities have infinitely many solutions, it is impossible to list them all out. We need to find a way to show all of these solutions. The only way to do this is to use a number line. you have to graph. Okay, so here we have x is greater than 7. Again, there's so many numbers that are greater than 7 that there's no real way for us to write that down. So what we do is we're going to use a graph and our number line and graph them. Okay, so x is greater than 7. We'll typically graph this way. I'm going to put 0 here. I'll put -7 here just to have some numbers out. So greater than 7, I'm going to put a circle here at 7. And greater than 7, I'm going to go to the numbers or to the direction that's more than 7 or greater than 7. So go into the right there. Okay. Number 2, m is less than or equal to 1. So make my number line 0. I'll put 1 here. I'll put -1 here. Okay, so 1 is the number. We're going to have a closed circle at 1, and we're going to go the direction of numbers that are less than 1. Okay. Notice the differences. When do you see an open circle? Okay, you will see an open circle if you have greater than or less than. Okay, that open circle indicates that this is the border, but this thing that I'm circling is not the solution. I want to get as close to 7 as possible without actually including 7. So I'm going to include an open circle to symbolize that 7 is not included. Okay, you'll see a closed circle when it's greater than or equal to or less than or equal to. And that just says, hey, you can include this. This is a part of our answer. Do not use shortcuts when shading. Please think about it. Okay. Again, going here, we're going to do this first one together. P is less than -4. Okay, I can put -4 here, 0 here, 4 here. You really could just put one number. I'm just doing this so you can think about where the bigger numbers are and the smaller numbers are. Because it says less than, okay, it's not or equal to, I'm using an open circle. And then I'm going to the direction of numbers that are less than -4. 4 is here. It's greater than -4. So I'm going to go away from 4. That goes to numbers that are less than. Okay, when the variable that you're trying to solve for is second, it is a good practice to always move it first. Okay, and when you're moving your variable, just remember that the alligator, our inequality sign in elementary school, the alligator will follow the biggest number. So if B goes to this side and 82 goes to this side, the alligator still wants to eat, or the crocodile wants to eat 82. So that's where its mouth is going to open to. Okay, so now I have B is less than or equal to 82. And this is a nice thing to do because if you, I know I said don't follow shortcuts, but if you notice that the inequality sign when the variable is in front kind of always points the direction that the line should go. Okay, but that only works when our variable is in front, so make sure you put the variable in front. Alright, do that for number 3 and bring that in tomorrow. Alright, we'll write a few inequalities and then that'll wrap up this first introductory lesson. So here we have a few situations. Let's read and write some inequalities. It says to do well in your test, you must spend at least 45 minutes studying. So I'm going to say M. Okay. It says at least. Does that mean that I want, so at least 45. 45 we know is going to be important. We're talking about the minute studying. Do we want M to be more than or less than or equal to? This word at least, I always like to think of money because it's easiest to kind of grasp. If I say, hey mom, I'm going to the mall, I need at least $10. If she gives me $10, I'll be pretty happy because I said at least $10, she gave me that. Okay? But if she gives me $9, I'd be like, that's less than that, so that's definitely not it. But the at least means that, hey, you can even include what I'm talking about. at least give me $10. So $10 is great. I mean, $10 is acceptable by what I've said in the inequality. So that means that I'm going to do an or equal to. Okay, in the same way it says a car can go at most 120 miles per hour. So 120, I'm going to go this car speed, but I'm just going to say C, this car. Okay. Okay, so 120 will be more than what I can go, will be at the top end of what I can go to, but it says at most 120. That means I can do 120 miles per hour in a car. So that means it's equal to. Okay, if it was going to be another situation, you could say the car can only go less than 120 miles an hour, so that we're not including it. Or I'd say you need to study more than 45 minutes, so that would be not including the 45. Okay, now let's look at some graphs. And looking at this graph, hopefully you notice there's a closed circle at -1. Okay, so -1 seems to be our top end. The circle's closed, so we know that it's or equal to, and the arrow's going left, so we can just go that way. It's going to say X in this case. There's no kind of situation or anything that I have to remember for here. Here we have an open circle. You'll notice that above the line, an open circle at -3, and the arrow's going to the right, so I'm going to point my inequality to the right. And again, we don't have any kind of context, so I'm just going to use X. Okay, alright, so that's your introduction to inequalities. Hopefully this is a little bit of a review. Can be some new stuff. If you have to think about it, or make sure you spend some time to get this down in your head: closed circle, open circle, going left, going right, variable in the front. Alright, we'll start solving these and talking about a little bit more complex situations as we go. See ya.